Okay, today we're going to have some fun with algebra. Today we're talking about in and out machines. They look a little goofy. Don't worry, I'm going to help explain them. There's two kinds. There's this input-output machine where you put a number in and something happens to it and then a different number shoots out. I can do it in table form too. This looks more adult. I put a number in and I do something to it and a different number comes out. And your job is to decide what happens. What happens when it goes in this input-output machine? Or what do I do to X to make it a Y? What math process am I doing? What's my rule? So, this is what you have in your notes. You have this input-output machine, and an 8 is going in and a 4 is coming out. A 14's going in and a 7's going out. An 18's going in and a 9's going out. This one's really easy. I even left the answer open because it can't be subtracting 4. This one's subtracting 4, but this one isn't. So the rule has to apply to all of the examples. And it can't be these two because these would make my number larger. And all of these numbers get smaller. So if a number is getting smaller, I'm subtracting or dividing. And in this case, I'm dividing by 2. Let's take another look at the next example. The answer's not on this one. The number machine uses a rule to change numbers into different numbers. The table shows what happened when different numbers went into the same machine. A 15 goes in, a 6 goes out. An 11 goes in, a 2 pops out. An 18 goes in, a 9 pops out. A 23 goes in, a 14 pops out. Are the numbers getting bigger or smaller? They are getting bigger. To make a number larger, I have to either subtract or divide. Multiplying makes them larger, adding makes them larger. So which of those two rules applies to all of the examples? You should already have this one circled. This one is the one that applies to every example. 15 minus 9 is 6, 11 minus 9 is 2, 18 minus 9 is 9, 23 minus 9 is 14. Take a look at this example. You are to copy this table into your notes. You are to tell me what the rule is. My hint is the numbers are getting larger because I have to look at these two examples. Whatever rule these two examples follow is the rule you apply to the 4 and this. This is a backwards. You have to work backwards to get that 75. What are they doing in this table? Tell me the rule, fill in the numbers. That's task number 1. Stop the video and complete that. And here comes task number 2. This one's easier. What's the rule? Tell me the rule and tell me the missing number. Put in a 12, get out a 26. What did I do to get that? Put in a 9, get out a 20. Those are my clues. So tell me what goes here and what my rule is. Stop the tape so you can figure this out, and you have one more challenge. This one's a big challenge. You may or may not be able to figure this out, but the easy piece is you have these rules here, so you don't have to come up with the rule yourself. I put in a 7 and get out a 15. I put in a 12 and get out a 20. I put a 15 in and I get out a 23. Those are 3 examples. What am I doing to get that result? Look, 2 of those are 2-step. use your math reasoning and figure out what the answer is to this third extra problem. If you can't figure it out, don't worry, we can solve it in class. If you have any questions, put question marks by your questions, and we'll talk about it in group tomorrow.